Assalamualaikum warahmatullahi wabarakatuh and good day. Welcome back to BKS 552 Construction Technology 4. Today we're going to continue on chapter of surface and subsurface water drainage and pipe works. Let's go. On our last week recorded video, we have learned on the surface and subsurface water drainage. For today's lesson, we're going to learn sewerage system and water reticulation. Sewerage refers to the infrastructure that conveys sewage. It encompasses components such as receiving drains, manhole, pumping stations, storm overflow, and screening chambers of the confined sewer or sanitary sewer. Sewerage ends at the entry of the sewage treatment plant or at the point of discharge into the environment. Contohnya, bila air daripada treatment plant tu pergi ke sungai. Sewage is generated mainly from domestic activities, either from household institutions, commercial areas, government complex, or industrial premises. This include all discharge daripada toilet, household washings, kitchen, laundrettes, bathroom, showers. So any air yang telah digunakan untuk kegunaan harian lah. There are mainly two types of sewerage system in Malaysia. The premises sewerage system are either one, connected to a public sewage treatment plant ataupun have an individual septic tank. This is the individual septic tank. Normally kita nampak kalau kat area rumah, kadang-kadang kita nampak ada manhole kan. So itu adalah individual septic tank. Yang for example, Indah Water Consortium akan datang and then dia akan sedut keluar all the sludge yang ada dekat level bawah ni. Dia akan sedut keluar semua. Then kita have to pay bill because of kita gunakan servis dia untuk maintain this septic tank. This one lah contoh septic tank. Septic tank dia punya manhole. Dan lori yang akan datang dan sedut the sludge. Premises with a proper individual septic tank has rectangular metal covers and is usually located outside the premises compound, either at the side, rear or front. The septic tank only provides partial treatment of sewage that flows into it and needs to be desludged on regular basis, approximately once in 2 years, to ensure that its function efficiently. Kena ada maintenance lah sebab sludging dekat bawah tu have to be bawa keluar, kena disludge lah. Malaysia's most common form of sewage system is the individual septic tank. There are an estimated 1.2 million premises with individual septic tanks in the country. So for example, if you look at here, ada rumah and then inilah septic tank dia. This is the typical type of septic tank, FRP, which is fiber reinforced plastic septic tank. So bahan dia adalah FRP. Septic tanks usually comprise 2 chambers and do not fully treat sewage. They are settlement tanks that require regular desludging. The maximum amount of sludge that septic tank can store is approximately a third of its total volume. Raw sewage flows into septic tank and solid matter or sludge settle at the bottom. Oil and grease from the sewage floats to the top, forming a layer of scum. Scum prevents oxygen from dissolving in the sewage and result in anaerobic digestion taking place. If desludging is not carried out, sludge level may exceed maximum level. Ini akan menyebabkan incomplete breakdown of sewage. Thus, untreated sewage and sludge solid akan release from the septic tank dan akan masuk pada drain. Where septic tanks have a filter bed after the settlement chamber, filter beds will become choke, akan tersekat lah, maksudnya sebab solid metals and whatnot akan block that filter beds. These two will result in untreated sewage and sludge solids being discharged into drain. Jadi akan masuk pada drain. Jadi akanlah ini akan menjadi pollution lah, sebab dia akan directly masuk pada drain. From this illustration, kat sini tunjukkan individual septic tank. So kat sini lah inlet daripada penggunaan, for example dari rumah, dia akan masuk pada this septic tank. Dan scum ni yang akan menyebabkan oksigen takkan lepas keluar. So oksigen ni akan berada dekat bawah ni lah. Jadi dia akan menyebabkan this anaerobic bakteria-bakteria semua boleh treat air dekat bawah ni. Dan sludge maksudnya yang berat-berat tu akan turun ke bawah dan jadi sludge kat bawah ni. Air yang ni akan keluar, kalau maksudnya dah penuh dia akan flow out, masuk ke drain. Macam itulah caranya. Septic tank a possible culprit pada pollution. So bacteria polluting the coast of Malibu, California may be coming from leaking or improper maintained septic tank. If you look at here, sewage datang daripada rumah ni, okay, and then masuk pada this septic tank. Because of water ni dia tak berada dalam septic tank ni at least 24 hours because dia dah terlampau banyak, dah overflow, dah terlampau banyak masuk pada di septic tank. Then sludge ni can be built up and forcing water out too soon or blocking the drain. That's why jadi pollution lah bila air masuk ke dalam drain. Apabila air yang daripada septic tank ni tak ditreat selama at least 24 jam. Sebab kalau di dalam septic tank tu bakteria akan work anaerobically. Overflow terlampau banyak, jadi drain ni akan keluarkan air yang polluted daripada septic tank masuk ke drain. This one is illustration daripada private sewage pipeline akan pergi kepada public sewage treatment plant, which is the STP. Public sewage treatment plant. This is the preferred and most expensive system. Pump sump is part of sewerage treatment plant. The installation produces a purified liquid outflow that can be discharged to nearby ditches and streams without causing pollution or water supplies. Similar to the septic tank, causes solid sewage to settle. For public sewage treatment plant, as you can see from the illustration, dia ada a few filtration system yang ada tank lah, dalam tank yang akan masuk pada aerated sewage. So masa ni lah bakteria-bakteria akan melakukan kerja-kerja dia untuk menambah baik air ni, and then dia akan pergi pada sludge removal dan akan pergi pada drain ataupun sungai ke any stream after settle the treatment. The first step is screening ataupun filtration tadi. The influent sewage water passes through a bar screen to remove all large objects like cans, rags, stick, plastic packet. Apa-apa je yang termasuk yang besar yang dia boleh screen, dia akan screen dulu. Then grid, which is the small particle removal, the next filtration system. There's a chamber, maksudnya ada area ruang where the velocity of the incoming sewage is adjusted to allow the settlement of sand, grit, stones and broken glass, benda-benda yang kecil. Then the aeration, air pump into large aeration tanks mixed with wastewater and sludge that stimulate the growth of oxygen, resulting heavier particles that will settle later in the treatment process. Jadi akan partikel-partikel yang ada tu akan settle dekat bawah that aeration tank. Next step is sedimentation or clarifier tank. The process of removing suspended solid from water. The tanks are used to settle sludge with grease, while grease and oil rise to the surface and are skimmed off. Dia akan dibuang. Any grease ataupun oil yang berada dekat top of the water akan dibuang. And then sludge removal, which is more sludge is disposed of in landfill and spread on land. Sludge tu yang daripada bawah septic tank tu lah, yang dah berkumpul, yang dah settle dekat bawah septic tank tu, sludge tu akan dibuang, didispose. And then disinfection purpose is to substantially reduce the number of microorganisms in the water to be discharged back into environment for later use of drinking, bathing or irrigation. Jadi dia akan hantar balik pada stream ataupun sungai-sungai setelah treatment selesai. This is the detailed illustration of sewage treatment plant. First, dia akan pump into this screening chamber. Akan dibuanglah yang solid, yang besar-besar. And then grid removal untuk screening smaller particles, smaller solid. And then masuk pada aeration tank where thereby the aerobic process is happening there. And then settling tank, the clarifier. So maksudnya kat sini ada sludging lagi. Kat sini pun walaupun dia sludge juga Here also ada sludge. And then akan pergi pada disinfection tank whereby letak klorin lah untuk menambah baik quality of water. Lepas tu baru masuk pada sungai stream The solid sludge yang settle below here akan dibuang lah, akan dihantar pada any landfill The example of reinforced concrete tank 3. Next is sewerage drainage. This is the typical arrangement of infrastructure facilities. As you can see, ni ada rumah berkembar daripada sebelah sana dan rumah teras. So basically the drainage akan duduk bawah jalan manhole semua dekat bawah. Principles of good drainage. Material should have adequate strength and durability. The diameter of drain to be as small as practicable. Maksudnya bersesuaian lah. Drain ni tak boleh terlampau kecil Every part of drain should be accessible for the purpose of inspection and cleansing untuk purpose of maintenance. Drains should be laid in straight runs as far as possible. Drains must be laid to gradient that will render them efficient. The material that's suitable for sewer pipe is RC pipe and HDPE pipe. RC pipe dah biasa sangat kita tengok kan. But the HDPE the features and the benefits. High performance HDPE used to withstand long-term environment and install condition. It is tough, high impact resistant HDPE to resist breakage. It's available in 20-inch length for shallow burial and shorter length for safely accommodate trench boxes. It is lightweight, easy to handle, easy cut in field. Bell and spigot joint for ease and speed of connection. High UV resistant for hassle-free storage. Heavier weight for deeper installation. Smooth liner for greater hydraulics. Extended bell and spigot for easier joint assembly and greater performance. This is the reinforced concrete sewage pipe. Nampak ni. And this is the HDPE, the spigot and bell Installation and laying of HDPE pipe. First, we need to excavate trench. Excavate and then level. Kena level the excavated surface untuk set up pada gradient yang sesuai. Then lay down the sand blinding untuk provide even surface pada trench ni. Compact the sand blinding. Right, dia tengah compact ni. And then lay pipe and jointing the pipe. And then kita backfill the excavated material and compact, right? And then this one adalah construction of the manhole. So manhole ni semua ada macam step boleh turun ke bawah dan boleh buat maintenance Dan siap dekat sini as you can see manhole yang telah siap. Manhole, it is an inspection chamber over 1 meter to invert level dekat sini. Compartment containing half round of channels. It provides a drain access point for cleansing and testing for maintenance. Can be constructed of rectangular or circular precast concrete. Ni circular. Rectangular. Access cover use general cast iron. This one dia punya access cover So kita akan sentiasa tutup lah, but if let's say ada maintenance, dan kita akan buka this cover. To clean the sewer, first, kalau ada blockage, full or partial restriction within the sewer and most commonly found in smaller diameter pipes. So dah block dekat sini. Okay. And another one is the sedimentation ataupun mendapan any settlable particulate material that may under certain condition form bed deposit in the sewer. So dekat bawah ni ada mendapan yang dia actually mengganggu flow of water tu untuk keluar disebabkan di sedimentation, dia mengecilkan lubang tu lah. So kena ada cleaning process for this. This is the example of cleaning pakai berus. So dia akan berus lah lubang-lubang ni sebab dia boleh masuk kan. So kita akan berus dan keluarkan any blockage yang terjadi kat dalam, bersihkan keliling dia ataupun pakai batang besi untuk tarik keluar all this mendapan-mendapan yang block dekat dalam this sewerage. When we install the sewage pipe, okay, we need to check juga dia punya gradient ataupun flow test. So kita buat water test. It tested by water pressure, water tightness under pressure and free flowing drain will never suffer. So ini yang kita akan test, water test. For this test, kita akan gunakan bola pingpong dan bola tenis. Okay, nampak dia letak dekat sini. So nak tengok flow dia macam mana. Kalau clear flow, as you can see, tennis and pingpong ball pass through. Sebab tenis ni dia akan turun ke bawah, dia tenggelam kan. Tapi pingpong ball ni dia floating, so dia akan berjalan. Okay. But if let's say there is a blockage in pipe, tennis ball ni takkan keluar daripada that sewer pipe sebab ada blockage dekat sini. And if let's say pipe ni tercurve what happen is pingpong ball takkan dapat lepas lah. So pingpong ball ni stuck dekat sini, whereas the tennis ball akan bergerak because of the flow of water dia dekat bawah. So mungkin flow of water tu laju, so dia boleh bergerak. Another test that we can use is by using a modern technology, CCTV. Visual inspection of inside the drain runs by the use of small camera. It provides a moving picture record on a monitor of the view of the inside of the drain. Jadi akan masukkan CCTV dekat dalam that sewage pipe and we can see what happen inside, how the flow of water and what not, sama ada blockage ke atau macam mana. So this is the CCTV test. Okay, you nampak ni ada screen So inilah dia yang beroda ni. Okay, so akan attach CCTV kat dalam ni. Jadi dia akan masuk dalam this sewer pipe. So dia akan kita akan nampak lah. Sebab ada wire and whatnot yang akan bersambung pada the screen and we can see what happen inside the sewage pipe. This is the typical cross section backlane for sewerage pipe wastewater installation. Next is water reticulation. The character of being reticulated or net-like, that which is reticulated, which is a network or an arrangement of veins resembling one. A network of crisscrossing lines, strand, cable, or pipes. Water reticulation system or water distribution network which have to be collected and then treated before distributed to the consumer. That is the definition. The reticulation system start at water authority main supply to reservoir, water tank to homes, factory, school, shopping complex, and many others. For commercial use or for hydrant, pipe. The main components for water reticulation system are bulk meter, gate valve, sluice valve, scour valve, A valve, and hydrant. For bulk meter, it is used to monitor large flow of water for water system management and commercial building purposes. For gate valve, is a full wave valve which is inserted in a pipeline for controlling or stopping the flow of water. For the sluice valve, it is used to control the flow of water. Cover valve is used to empty the pipe when necessary to make repairs or cleaning. A valve is used for controlling and exhausting air from water pipe. And hydrant, it is a discharge pipe with a valve and spout at which water may be drawn from water main. This is used for firefighting purpose. The material used for water reticulation piping is ductile iron, steel, asbestos cement, reinforced concrete, UPVC, or HDPE. There are factors to be considered in choosing the material for the pipe, which is location of the pipe, whether it is laid on the ground or in trench, the corrosive nature of the soil and groundwater. Sebab kita nak tengok takut dia akan react pada the pipe. Life cycle cost, which is the initial capital cost plus maintenance cost. Size or diameter of the pipe, because we need to know the amount of water to be supplied. Different type of material has a different size. Duration of the pipe to be used, soil condition and characteristic of the pipe. About the weight, maksudnya mungkin susah nak install kalau kita gunakan RC pipe untuk certain area yang mungkin terlampau berat. Ductile iron pipes, it is a high quality steel mold. Fitting are cast by pouring the metal into steel or sand molds. Has a small quantities of magnesium which increase the tensile strength and make it stronger and less liable to fracture. Kuat lah. Low maintenance cost. And for the steel pipe, it is one of the cheapest form of service pipes. It can sustain high pressure. It can be laid in corrosive soil because it sheathed with bitumen. Salutan bitumen yang protect the surface of the pipe. Heavy to handle and hard to bend. Asbestos cement pipes. It is made of Portland cement and asbestos fiber mixed in slurry. It is cheap, resistant to internal and external corrosion, but they are brittle, so must be handled carefully. Reinforced concrete pipes, it is commonly used. The size is between 400 mm to 1800 mm diameter. The characteristic is corrosive resistance. They need special protection if the groundwater is saline or otherwise aggressive to concrete. So mungkin akan kena corrosion lah because of this salt water. UPVC pipes. It is resistant to corrosion, light in weight and will not affect the taste, odor or smell of drinking water. Not commonly being used, however, it is easily to break. HDPE pipes, very cost effective, effective for above ground surface, buried, floating and subsurface marine application. It is lightweight, strong, extremely tough and very durable. However, fewer fittings due to pipe flexibility. There are 6 methods of jointing, which are spigot and socket joint. This one, welded joint, butt fusion joint, flange joint, flexible mechanical coupling, and compression joint. The method of construction for water reticulation system will start with excavating trench and then lay blinding with the soil and then laying of pipes and the covering. Install the pipe fittings such as hydrants, valve, band, pipe crossing, and then do the testing. In Semenanjung, Malaysia, the water authority is led by Kementerian Tenaga Teknologi Hijau dan Air, which is the Suruhanjaya Perkhidmatan Negara. It is the regulator. And it's also under the Ministry of Finance, where pengurusan aset air dan aset air sendirian berhad. And water supply service, as you can see here, it depends on the state, each state in Malaysia. And for sewerage services or state is IWK, Indah Water Consortium. This is how water supply system works. This one is water catchment area. So air hujan semua akan turun lah kawasan tinggi . And then it will help at impounding reservoir. Ditahan dekat sini. And raw water intake pun ada pumping station. Mungkin akan masuk juga dekat this impounding reservoir. And then there is a treatment works happen and balancing reservoir. Next it goes to the pump station. Untuk pump ke kawasan yang tinggi untuk didistribute pada consumers. But untuk kawasan yang rendah, okay, dia pergi pada another service reservoir and it goes to the consumers. Raw water source, actually the concept of raw water source above here on the top of the hill like that, it is suitable raw water source because of low contamination. Dekat sini macam kurang development and air yang datang daripada bukit ni lebih bersih lah. Dia kurang bercampur dengan air yang belah bawah ni because of this one dah ada development and so on. And air pun mungkin mengalir daripada kawasan-kawasan yang development dekat sini . This is the typical water demand guidelines. Depends on the type of water demand. For example, housing, hotel, commercial, industrial, demand dia berbeza . Berbeza mengikut jenis-jenis ni. Typical water supply schematic. This is the treatment stage where the intake akan pump up pada treatment work, high ground level and then akan pergi lagi pada another balancing reservoir. And dia akan pergi kepada break tank. Dekat sini dah start distribution stage. Dia akan turun lagi kepada suction tank. And then dia akan pump up pergi kepada another tank kat sini untuk distribution which is the consumption stage . Kita dah nak consume bagi kepada pengguna. And this is the service area and then pergi pada fire hydrant lah, hydrant . Water reticulation system biasanya dah ada dalam development master plan. So dia dah fokus untuk 20 years in the future. Macam mana penggunaan air untuk negara lah, for example . This is the estimated water demand. This is the ultimate project demand year 2040. So bila makin banyak project, so the consumption of water akan semakin bertambah. So ada water supply planning lah untuk water demand . If you see projected water demand, okay, daripada 2008 it is 19 million gallon per day. And it is estimated in 2040 it will become 98 million gallon per day. Berbeza mengikut land use masing-masing lah. Jadi kalau development semakin banyak, semakin membesar development tu, water demand akan semakin tinggi. So ini 2008, 19 establish water demand and ultimate project demand which is in 2040. This one . The topographical map for the project site, okay, kat sini. Okay, so impounding reservoir, so kita nak tengok dari mana sebenarnya source of water yang kita nak distribute kepada area yang kita nak develop. Water intake going to come from here, Wantan and then akan pergi pada project site. This is the water intake from Kampung Kobat Baru and then dia akan go for treatment. Baru dia akan pergi kepada project site. Raw water intake structure. So weir ni is actually a low head dam as a barrier across the width of river yang alter flow of water. So maksudnya akan ada macam perubahan bertingkat-tingkat lah, berubahnya height of the river level. Biasanya ada dekat kawasan macam lake, ponds and reservoir yang kita nak control flow of water tu. For water treatment plant, it will start first at the reservoir and it will go to the aerator untuk aeration process and then coagulant added. Okay, coagulation treatment ni usually kita carried out before the filtration and sedimentation process. During this process, coagulant ni added to water, so positive charge akan neutralize the negative charges of suspended contaminants. Therefore, the neutralization causes the suspended particles untuk bind together. Clumps, dia akan jadi clump, dia akan flock, dia akan bergumpal lah. And these particles akan sink to the bottom of the treatment plant. So dia akan jadi sedimentation macam ni lah. Jadi dia lebih senang nak di-filter out daripada water. And then it goes to the filtration. And then filtered water storage. So kat sini kita simpan air ni. Distribute to the consumers. Okay, the sludge will be dumped lah dekat landfill. How the water is being distributed from the Semambu treatment works, it use the gravity flow daripada ground level yang higher pergi ke lower ground level to the supply point which is 37 ground level 37 meter. Water distribution here, as you can see, there is zoning 1, 2, 3, 4, 5, 6. Okay, so the development phasing, okay, by zoning, reliable distribution system, it will, the construction is more effective in cost, it is easy of maintenance and control of non-revenue water. Non-revenue water ni actually water yang loss before it reach the consumer. Mungkin ada leaks ataupun dari segi metering punya inaccuracy This one lah dari zone dia, zone 1, zone 2, zone 3. So daripada balancing tank yang high ground level akan pergi ke lower. Okay. Residual pressure turun lagi dan turun lagi kepada lower level. For the distribution storage tank, it is a mandatory to allow for 1 day storage, 1 to 3 days tapi 1 day mesti cukup lah untuk storage. This is the example of water tank, water structure yang store the water. Water pumping has two main purposes, which are to transfer of liquid from one place to another place and to circulate liquid around a system. Water pumping is used if there is need to move the water to the higher ground level. For example here, then you need the pressure booster ataupun pumping dekat sini untuk pump the water up. Untuk this development, so water reticulation for zone 5 kalau you tengok dekat sini, so zone 5, so ada satu service tank yang akan store the water and water ni akan go on loop, dia akan berpusing pada this water reticulation system, dia berpusing so mana yang diperlukan akan pergilah dekat that part kat mana yang diperlukan air tu. Well, actually, calculation ni tak perlu pun tahu macam mana cara dia kira. But this one is additional saja. I tak explain lah. Okay, for water reticulation system, ada EPANET software package. This is the Dynamic Water Distribution System Simulation software yang released by US Environmental Protection Agency for both utilities and consultants. So, senanglah untuk buat simulation dan boleh forecast dan boleh planning how the water distribution system yang nak dibuat. This is the example how the analysis using the EPANET version 2.0. So dia ada calculation already, the residual pressure and whatnot semua eh. Knowledge has always been important, of course. The ancient Egyptian did not raise the stone for the pyramids, relying on the incantations of their gods. The water in the irrigation canals of the great Hindu civilization did not flow according to the law of ignorance. Knowledge has always been power and wealth. This is the quote from our former Prime Minister, Mahathir Mohamad.